Hi, everyone. My name is Mike Alonzo. I'm an associate professor in environmental science at American University, and I'm just sharing this presentation about monitoring the neighborhood air cooling effect of forest patches using bike-mounted thermometers that was presented in October at the Baltimore Ecosystem Study Conference. And this is intended for volunteers who participated in the project or anyone else on the internet interested in learning about this cool work. So, first of all, we're looking at a forest patch, and with the addition of things like wind and other environmental factors, we wonder how this forest patch may or may not cool the neighboring areas and how that cooling effect is going to be mediated by wind direction and wind magnitude. So it's one thing to cool a parcel of air sitting on top of a forest patch. It's another thing to move that parcel of air over to where people can actually be cooled by it. So this has implications for urban design and how we prioritize tree planting and maintenance, for example. So that's basically the question we are asking about cooling near these forest patches. And this project came together because it builds on local interests in Baltimore. For instance, the Johns Hopkins and BSEC fixed temperature sensor networks around the city, and forest patch maintenance and conservation community engagement from the nonprofit Baltimore Green Space. And also from the American University perspective, I've had this temperature bike built since 2020, and it's made it on the media a few times, but it needs to be doing a little more to advance the science and advance the policy of urban trees and cooling. So here's the general project timeline for that culminated in mapping temperatures in August and September of this year. The long and the short of it is that I built this bike back in 2020, relying on some instruction from Carly Zeiter, who did this in Madison, Wisconsin a few years prior. And we brought together Darren Waugh from Johns Hopkins and some other folks around Baltimore, including Baltimore Green Space, who put in some money and some time and built a few more bikes based on the model that I had in 2020. And then we thought, well, we don't want to just go out and ride around and collect a bunch more air temperature data without a particular goal. So we asked, what is the point of having 4 bikes exactly? And so we thought, oh, one interesting use would be to basically ride in circles or zigzag patterns close and far away and in various directions from a forest patch to see both where is being cooled, near versus far of the patch and when. So it's essentially continuous monitoring of air temperature near forest patches over the course of even a full day. So what you're seeing here is a few of the intrepid volunteers who came out and got to ride these awkward bikes around, as well as a beautiful t-shirt designed by a high school student, Elise Baker. So our first campaign was on August 24th, and you're just seeing some pertinent information from a few of the nearby weather stations to kind of just show the conditions. And so we'll start with temperature. You can see it went up to 29 Celsius or something, a little bit choppy, and then drops down after 5 or 6 p.m. And then importantly, we wanted to characterize the wind speed and direction. So basically, this is wind speed coming in from the north here at 0 degrees or coming in from the northwest. And so that means the parcel of air is going to go 180 degrees in the opposite direction. So kind of southeast is what we'd expect as far to see a cooling effect. Now, this was not the greatest day in the world for doing this. It was a bit cool with patchy clouds, and so we may not see that contrast between forest cooling and just the rest of the neighborhood. Here's our data collection grid. So first of all, we have the forest patch here, Chinkapin Run Park, or Sycamore Woods, I think it is also called. And we have these patterns of a root pattern that's radiating in and out from the patch in as many different directions as the street grid would allow. And so you're actually seeing the data themselves. We zoom in on one grid here, grid 97, and all of these points are data collected by several different bikes, which are color coded at every second. So we have a lot of data that's very similar to the data point before and the data point after. So we're going to summarize this data, like take an average at 5-minute time steps within each of these 100-meter grids to get a final map and a final animation. So grid 97 was where our home base was. It's also one of the cooler locations, given its location relative to the patch. Contrast that to grid 141, which is both far away from the patch and near a lot more impervious surface in the form of Loch Raven Road. So here's kind of the technical part here. These are looking at those two grid squares over the course of the day. So let's just look at grid 97 here. And these are all of the 1 minute averaged temperature points from the 4 bikes that were transiting through that area. And so the main point to note is that we have temperatures being collected from about 1 p.m. until a little after 7 p.m. And you can see there is a general curve. And so this is just basically the weather changing through the day. This is not necessarily the impact of the patch itself. So essentially, this is the trend that we want to account for and remove so we can better understand how the temperature is changing spatially based on things like location relative to the forest patch. So you can see it gets warmer, peaks around 4 p.m., and then starts to go down after that. And you'll see that in the animation in a little bit. Same idea for the warmer patch, but maybe it starts a little warmer to begin with. And so here you go. Here's the raw mobile temperature movie. There's no legend here because the specific values don't matter so much. It's more just you can see over time it gets warmer, and then now you're seeing it getting cooler. And there's some evidence that the temperatures are generally a bit cooler, closer to the patch itself. But again, it was a hard day to kind of suss out these subtle trends due to the patchy sun, cooler weather, shifting winds, etc. So we can account for this a little bit, this like these temperature trends throughout the day by detrending, by removing that day-long effect and just taking the average at each time step. So these are two different ways of approaching that. And I won't go into detail, but you can get a better idea that it's, particularly on the right, I think, that there's some cooling happening near the forest patch, and particularly on the southwest area over here, it's generally a bit warmer. You can also see that now we have a wind arrow that shows both the relative magnitude and direction that the wind is going. So you might expect the most cooling to be happening over here, which unfortunately is where we can't actually collect data. So it'd be great to have the wind going in a little bit different direction. So since we didn't love the weather conditions on that day, we decided to come out again on September 13th. And so again, we've got the temperature stations nearby showing, luckily showing pretty similar temperature patterns between the two of them, as you'd hope. The wind direction and magnitude is pretty similar to what it was the last time, wind coming from the north, or even more so from the northwest. So this day was a little more warm and consistently sunny, so we might expect to see more of an effect from the forest patch. So, of course, as it goes, nothing's perfect here. So the weather was good, but there was bike problems. The GPS wires popped out a few times, and so it was a little harder to collect good data. And so we only got partial data within about a 3-hour time span. And so you're seeing basically the same thing here. The grid is slightly different because a few people got lost and went off script a little bit, but that's okay. It's just more data in more areas. So this is the data from two different grid squares again, and the main point here is just to show these large gaps in the data between here. It's 1 p.m. and 3:30 p.m. And so there's not enough information in there to really fill in the gaps. So this is a bit more of a problematic data set. Now in this grid square over here, it happens that the data are a bit more evenly placed. And so this is more what we would want to see ideally. So this all results in a movie. And so this is the raw temperature movie again. So you're seeing both the change in temperature just over time and by space. But you can see there's, nobody's writing. And then, okay, the writers come back for a little bit and hang out in the south area for a little bit while we're fixing some other bikes. And then eventually a rider or two goes out in the north again. This is the anomaly movie, meaning this is the change over time has been subtracted out. So you're supposed to see a better depiction of just the change in spatial temperature. But again, hard to see today. So that's it. We're so far through the initial data collection period, but we'll go out again next summer to try to catch more idealized days. And then we'll move on to some analysis to both understand how the temperature changes over space and time. And then we'll have to add in more variables because, of course, the temperature at a given location is not just influenced by its distance and direction from the patch, but also by the characteristics of the grid cell itself in terms of impervious cover and other trees that are out there, as well as the characteristics of the neighboring grid cells, these kind of neighborhood effects. Imagine a grid cell being surrounded by a bunch of parking lot versus surrounded by other houses with trees. So there's a complex analysis to do, but having some fun movies, of course, is the first step. So thank you to all those who participated, and we'll look forward to getting you on those bikes again to collect some more data in next spring and summer maybe.